Hello class, thank you for joining us today for our presentation on code coverage. This presentation was created by Phillip and Derrik Milligan. Let's start with the definition. What exactly is code coverage? Code coverage is a metric that is generated alongside your tests. Now primarily this is done with unit tests. And what it does is while your tests execute, it counts the number of lines that have been executed while your tests are running and compares them against the total number of lines in your program to give you a percentage of how much of your code is covered. So let's jump into the demonstration. For our demonstration today, we're going to have a real sample code module that we're going to write some unit tests for, and we're going to run a code coverage report on to see how well our unit tests fared. For the programming language we'll be using is JavaScript with Node. We're going to be using the Node package Mocha for running our unit tests, and the package Istanbul for generating our code coverage reports. We're not going to go over how to set up our little environment and installing all of these things, but we will jump into the code. So, jumping into our code, here we can see our little module that has two functions, an add function which takes two inputs and we'll add them together, and a divide function which takes two inputs, checks to see if the divisor would be 0, and if it's not, then it will just divide them. Now this could also be more inclusive to validate that the inputs are numbers and handle floats, but we're just keeping everything very simple today. The one thing that I want to have at the forefront of your mind is on line 8, where we have our if statement to check the divisor and return undefined if it's 0. Now let's take a look at the unit tests for our module. We see that we're importing a few things, including our module, and we're going to have a suite called math functions that has an add section and a divide section. So in our add section, we have one unit test that will give the inputs 1 and 1 and expect that the result of that would be 2. Seems good. It's covering it. Now we have a unit test for our divide function that will give the numbers 4 and 2 and expect the result to be 2. So from a pure unit testing standpoint, this could feel really good. It looks like we've written a unit test for every function in our module, which is normally a really good thing to do. We've verified that it's working. These tests are passing 100%, but they're not quite covering all the code, as we'll see in our code coverage report. Here is the output from our code coverage report. Now, we know that we were passing our unit tests 100%, but when we look here in our index file, which was our module, we can see that it says statements 80%. It doesn't look like we have 100% code coverage. If we inspect it further, we'll notice that it's got a red line on line number 9, indicating that we never reached line 9 during our unit testing. So none of the unit tests ever caused line number 9 to be executed. And this is where code coverage begins to differ from your testing, because it doesn't necessarily care about how many tests were written. What it cares about is how many of the lines of your code were executed. And so in this case, only 80% of our lines of code were executed, as opposed to 100, which is what we're going to shoot for next. So now, having seen that our code coverage is not at 100%, we're going to come back to our unit tests and remedy that. we're going to create another unit test that will check our divide function. And this time we're going to pass in a 4 and a 0 and expect that the result of that is now undefined. This should fulfill our needs to have 100% code coverage. So now let's run our coverage report again. And looking at it, we can see that we have 100% of statements were executed during our unit tests. Woohoo! That's what we were going for. One thing interesting of note as well is that if you look just next to the number 8 in our line numbers, you'll see there's a 2x. And this is indicating that this line of code was executed twice during our unit tests, as we had to run this if check twice. That's just another tool at your disposal to understand how your code works while it's being ran.
There are quite a few upsides to code coverage. It is simple to implement, and automated reports are easy to generate. Code coverage tests are a good measurement of how much test-driven development has been done and the quality of the code being written. It is also a very good way to capture bugs early in development. There are also some downsides to code coverage testing. For example, it costs development time and does not find all the bugs in the code. Even a coverage of 100% does not guarantee the code is bug-free. Also, each programming language might require different coverage tools, which would mean finding and setting up multiple code coverage tools if multiple languages are required. Code coverage testing is recommended for unit-level testing to lower the chances of bugs early in development. It is also recommended to monitor the amount of tests developers are writing. Some major IDEs come with code coverage testing tools and recommend using code coverage testing. In conclusion, code coverage can be very useful to find bugs early in development and should be a normal practice for developers and testers to show good test-driven coding practice. However, it should not be used exclusively. It should be used with other code testing practices. There is no set coverage percentage to shoot for, and most IDEs have either add-ons or built-in code coverage testing. Code coverage testing is fairly easy to implement and generates useful reports and shows trends of development test-driven practices.
Here are the sources that we used while researching code coverage.
Thank you for watching our presentation on code coverage testing.